Good evening, everyone. Welcome to today's session. Welcome to day 4 session of getting started with the basics of ML. And today we are going to learn about clustering. Um, okay. So, all right, everyone. So, till yesterday, we learned about supervised learning, right? Uh, we learned about we learned about both classification and regression. And yesterday, on day 3, we learned about regression, right? So, what is regression? It is a type of supervised machine learning. See, just like classification, regression also has label data because it is supervised machine learning. See, in classification we had like categories or like labels, like spam, not spam, like that. In regression we had some kind of number. Okay, we had continuous numerical values. So that is the difference between classification and regression. And we saw some we are predicting a continuous value here. So we saw some examples of regression like house price prediction, where the inputs, like they can be the size of the house or location or something like that, and the number of bedrooms or something, and we are predicting the price of the house. Maybe it's like some 50 lakhs or 60 lakhs. We are predicting the house price, which is a number. And then then there is another example. We have temperature forecast, where we are predicting the temperature like based on the wind or the humidity or those kind of things. And for in the next we have student score prediction. For that, they're like, we can use like study hours, or based on the features like study hours or something. We can predict the marks of the student, the score of the student. And then we have car mileage estimation, again based on car properties, maybe the engine size and fuel. We can predict the mileage. And then we have delivery time prediction, and then we have stock price prediction. See, there are so many examples. We discussed yesterday about these in detail. And then we have, then next, yeah, we discussed about the data. And here the input will be like the features like what they are, like characteristics, something kind of those, like maybe the size, height, whatever, weight, what traffic conditions. For the delivery estimation one, we had those kind of things. And then the output will be the label. Okay, the output will be the label. And and then we also have metrics. We discussed about metrics. And in metrics, we see, in classification we had all the things like accuracy, precision, they call f and score, right? Now here in regression we had MAE, mean absolute error. See, this is just like the average of the absolutes of the errors means the difference between the predicted value and the actual value. And then we have mean squared error, like instead of doing the absolute, we are doing square here. And then RMSE, we are just calculating the root for MSC, root mean squared error. And then we have R square score. This tells us like how good our model is fitting. Like, if you guys remember, one is for like one means the model is good, one means the model is great, and zero means it's not that great. We need to improve our model. So, like, it doesn't tell about the error; it will tell how good is our model. That is what is R square score. And then we discuss about types of regression. Simple linear regression is just like one input feature. The relationship between them is like a straight line. Okay, that is about simple linear regression. And then we have we discussed about an example also, right? The experience example. As the years of experience increase, the salary might also increase. So that we discussed about that example, and this is the relation we have, that the equation. And then we discussed about multiple linear regression where there are two or more features. Okay, in simple linear regression, we are depending upon only one feature. The relation is depending upon only one input feature. But in multiple linear regression, there are two or more features. Okay, but the relation is linear. Relation is linear, which means it's like straight line. Okay, but it has multiple features. So, like for example, the house price prediction, where the prices of the house depend on the size, the number of bedrooms, and more features. And then we even discussed about polynomial one. I think I missed that one. Polynomial where the relation is non-linear. Okay, the relation is non-linear, and for example, it is like the temperatures on a single day. At morning, it will be little less. Afternoon, at noon, the temperature might be at its highest. Evening, it will cool down slowly, and night, it will cool down a lot. How the temperature is not increasing linearly or decreasing. So that is polynomial regression example. So that's what we learned about regression. So see, we actually covered entire supervised learning the yesterday and day before yesterday. On day 2 and day 3, we learned about classification and regression. So that's it about supervised learning. Now we'll go to the next type of machine learning, which is unsupervised learning. Okay, so we are moving into the unsupervised learning. And what is unsupervised learning? I think you guys remember, right? What is unsupervised learning? Please put your answer in the chat box. Do you guys remember about unsupervised learning? Yes, finds patterns in data without being provided with labeled outputs or predefined categories. Yes, basically it is unlabeled data. What you said is right. So we are dealing with unlabeled data. In unsupervised learning, we are dealing with unlabeled data. So see, like the unsupervised, it itself says like we don't have any labels, so which means we don't know what is the actual output before. I think you're understanding, right? You don't know the actual output before. Like for these classification and regression, we can understand, right? What is the label? I'm talking about the test set. We know what kind of what is the label for it, but we don't have here. So that's what, then what did I say for this? I think if you remember, for the day, from the day one session, I said it will group something. It doesn't have any labels, but it will group into uh, some clusters. It will group into categories. It will group into categories, but these categories don't have a particular name. They don't have any name. So they don't have any labels. They don't have a category name. So that grouping is itself known as clustering. Okay, that grouping is known as clustering. um, 1 minute. Yes, so this is unsupervised learning. And yeah, we are dealing today about with we're dealing about color clustering today. So see, clustering is, yes, grouping similar things without any labels, without any the names, group names. So it's just like sorting some box, like a giant box of Lego bricks. You see here, there are different types of Lego bricks, right? There are some of these bricks will be small, some of these bricks will be big, some of them might be in different shape, they have different colors. So we don't know, we cannot properly group them. Like they don't have a particular name. These are just characters, right? The yellow color is a character, small is a character, shape, maybe a circle or round, rectangle, square, all these are characters. they're not the names for them. So see, now when you're forming these into groups, you'll take all the yellow color bricks, you'll put one side, maybe the yellow colored rectangle ones in one group. You'll form like this, but they don't have a particular name. So that's how classification happens. um, see So why do we even need classification? See, it can clustering, clustering. Why do we need clustering? See, it helps us find the hidden patterns even in unlabeled data. So see, if you remember the classification example, see, I said about how the spam mails can be detected. Based on, it will see all the spam mails, and it will then see a pattern, and based on that pattern it can classify, right? But here clustering, it itself will find some hidden patterns. Okay, so same as classification, but here it will find the hidden patterns in all unlabeled data and then categorize it. Okay, so it can organize all the large and messy data sets without even knowing the labels, without even we classifying them before, we grouping them before. We can easily use clustering to easily categorize them. Like we don't even see, if we don't even know some particular data, like, or like, see, particular category, if we don't even know them, we can use clustering, so that some even hidden categories or hidden characteristics can also be found easily. For suppose you can, here is another example, also a simple example. See, there are so many kind of sweets here, and we might not easily understand which one is which one. See, there is this golden sweet, gold color one, and then there is here another one. Based on these characteristics, we can simply uh, form as categories. So that's it. Like, just we can simply form as categories. We needn't name them. Like how I said in the Lego example, same here also. So this is just one more analogy. We have next. Yeah, I said about this diagram in the starting, on day one in starting class. Look, we don't know, like, we don't know these names. I mean, the machine don't know these names. We're just giving random things, random input, and then it will see, okay, this particular three elements have something like wings, and they have wings, and they're in yellow in color, and they have black stripes on them, something like that. It will see those characteristics, those kind of patterns, and then form a cluster. And for honey also, it is like stored in some container, and it is like yellow in color, something like those kind of patterns. It will recognize those kind of patterns, and then it will form a cluster too. And when you give a new input, when you give a new input like this, then it will say, okay, this uh, particular input has some wings, and it is yellow in color, it has some black stripes. So based on that, when you give a new input to the model, it will predict the cluster it belongs to. Obviously there are no names, right? Since the cluster one has these kind of properties, it will just say, okay, it will belong to this particular cluster. So that's how this clustering happens, and we'll see some real life examples. See, customer segmentation is one example. See here, we like companies, generally companies or like organizations, whatever, they want to group their customers into categories. Like, for suppose you take Amazon or something, they want them to like group them into categories, but beforehand itself they don't know how to classify, like they don't know the groups beforehand. So when we'll give the like the entire history of the customers to the machine, like for suppose it can be like purchase history, or maybe the amount of products or whatever, those kind of things. When you give them to the machine, the machine then might cluster them into maybe into groups like budget shoppers, or trend followers, luxury buyers, or maybe even like someone who are like regular customers, or who come yearly or who come monthly, maybe like that. Based on how the data is there, the machine itself can group the data. And then we even have another one. movie recommendations. See, think of this uh, see in, for suppose in Netflix, the machine will look into your like viewing habits, maybe your ratings. You might give ratings about a movie, right? You might give a thumbs up or thumbs down or something like that, and based on that the system can cluster viewers. Like if you end up if you end up putting a lot of thumbs ups to a action movie, then you will be in a cluster of action lovers, maybe action movie lovers, and there might be comedy movie lovers, like that. Okay, you can be grouped like that, and then based on that particular group, for suppose if you like more action movies, then obviously like that there will be so many users, right? After forming that cluster, then it will see, okay, which movies you did not watch, which movies the other people who are in that cluster watched, and based on that it can recommend you a movie. So like, you see, the machine can recommend movies the people already watched and you did not watch in that particular group, and so that you might, because you might like that. Okay, so that like that it can give you movie recommendations. And then we have like document organizations. Maybe like, you see, you can give so many research papers also. See, often these research papers are very confusing at the start. So when you give so many kinds of research papers, it can go through the entire document or something, and then it will give a particular domain which it can belong to. Like you give some thousands of research papers, or maybe a particular part, like maybe like abstract or something. If you give them and you don't know which particular domain it belongs to, so clustering can group them, and one maybe like, yeah, see, machine learning papers, or some biology related papers, or physics related papers, or some web development related papers, or whatever. It can organize data like without you needing to label them, okay, everything manually, every research paper. And then we have one more, astronomy data analysis. um, See, in astronomy also, like there are, see, you can see there are so many stars, so many astronomical objects present in our galaxy. So scientists will have so many related data. For suppose if you take star related data, stellar data, in stellar data there will be so many huge amounts of data related to stars. So they can see the star brightness, or the star temperature of that star, or maybe other properties. There are so many other properties of stars, and the machine will see all those properties, and it can help group the stars into categories, maybe like red giant, white dwarfs, or so many categories are there, so that it will be easy for scientists. Okay, it will be easy for scientists. So I think you did understood what is the difference between clustering and classification, basic difference. See, after all the segmentation, after all the clustering segmentation all happened, we humans can analyze, maybe we human can analyze the cluster one and cluster two, and we can name them. Like for the customer segmentation also, it cannot directly give them a particular group as budget shoppers or trend followers or something. It will just give us cluster 1 and cluster 2, and once we can just analyze it a little, and we can name the clusters. Okay, humans can name those clusters. So it's just the machine will notice all the characteristics, all the patterns, even the ones we may not have noticed, and then it will form groups. Okay, so these are some of the examples. Now we'll look at types of clustering. Okay, so there are mainly four types: partitioning methods, hierarchical methods, density based methods, and grid based methods. So we'll learn about them one by one. So partitioning methods. So let's start with the first type, which is partitioning methods. So partitioning simply means like we divide the data set into like fixed number of groups. Okay, we divide first them firstly beforehand only we divide them into some groups. We may call them as k clusters. Okay, k clusters. So like firstly we have to decide how many groups we want. Okay, we have to decide how many groups we want. See, the okay, there are two types. I mean, two algorithms: k-means and k-medoids. Okay, so the most famous one is here k-means. It is the most famous clustering algorithm, which is k-means. Um, I'll tell you, I'll tell you with a simple real life example. For suppose in our class, let us take our class, and there are like so many students, right? We want to divide those students into maybe into some groups based on their height. Okay, we want to divide them into groups based on their height. So we decide like we want three types of groups. We want three types of clusters. See, I'm deciding beforehand only. I want three groups. Okay, that is what is clustering. Sorry, that is what is partitioning. Okay, partitioning method. We have to decide how many groups we want beforehand. So I want to divide these students into three clusters based on their height, like who are short, medium, and who are tall. Okay, so here see, k means k here is the variable. K is the variable, like how many groups we want, that is k. So here k value will be 3. Okay, k value will be 3. So what this will do? Okay, K means will firstly pick 3 points. Like it will pick 3 points, like to act as centers of these groups. Okay, it will pick 3 points. Maybe like 150 centimeters, 165 centimeters, and 180 centimeters. Okay, K will pick these values. These are the centroids. Okay, based on these centers. Okay, these centers are called centroids. Okay, these centroids, based on these centroids, each student will see the centroid. Okay, each student will see the centroid, and which is to their closest height, they'll go in that group. Like group 1, people who are close to 150 centimeters, group 2 who are close to 165 centimeters, and group 3 who are close to 180 centimeters. So if I suppose if somebody is like 164 centimeters, they'll go to group 2 because they are near to 165 centimeters. Who somebody who's like 185 centimeters, they'll go to group 3 because group 3 centroid is 180 centimeters. So based on which point is closest to their height, they themselves will go to that group. Okay, so like that, so each student and the class will look at those centroids and see whichever centroid is closest to their height, and they'll join that group. Okay, so after all that, then I see after all that, then it will see, then it will, like all of them will be sorted, right? Like see, all in the short group, all short people will be there. Then now what happens is after this dividing, it will calculate the average again. Okay, the k means will recalculate the centroid. I mean the average centroid again of each group. Like all those people who are near to 150 centimeters will go into short person's group, but it will still recalculate to get the perfect centroid, like the actual, I mean the correct average accurate centroid. Okay, so for suppose if there are so many people who are like little above 150, then the average will not be 150, right? It might be 152 or something. If there's some more people above 150, like 150 to 155 range, if there are more people, maybe the average will not be 150. It can be 152, 153, maybe like that. So that's why it will recalculate, and this process repeats like after the centroids change a little, then maybe based on the student's height also they can change the group. Okay, so students keep reassigning, and until they'll do like this. See, for suppose there is some person who is like 155 or something, maybe like 157 or something. So he went to maybe 158, let us suppose 115, and he went to the second group 165. Now based on this average of short people, maybe if this average increases, maybe it went like 154 or something, then this person should come to here. This person should shift his group to here. Okay, so it will recalculate like that, because we can't really say all people are below 150. There might be 150 to 153, the starting height all can be 152 or 153, right? So the centroids will be recalculated again and again, and based on that some people might shift their group if the average changes, and it will keep on happening like this until the groups will not, like groups stop changing. Okay, at one point the groups will stop changing, because you will find the perfect accurate. See, the first one, what I said, 150, 165, and 180 centimeters, they're just initial, we are just initializing them, that's it, they're not the final centroids. We are just putting those one, and we started grouping them, and we are recalculating the centroids again and again. And based on that, some of the students might change their group. And after that, when after doing this process again and again, there will be at one point, the groups will not change, and that is the final groups. That's how we can divide them into three groups. Okay, here this is what is k means. K medoids is also very similar, except like average, except calculating the average, it chooses only one actual student from the group. It will choose one particular student, and it will then change based on them. Okay, so it will be like this for the k medoids. So this is what is partitioning method. Like the centroid will be the average actual data point. Okay, then we have hierarchical methods. So the second type is hierarchical methods. So here, like instead of see, like deciding the number of clusters at the beginning, we will build the cluster step by step. There are two types to do this. So agglomerative and divisive. So in agglomerative, it is like bottom up approach. See, we'll take each student. Okay, we'll each take each student. Each student is one group. For suppose if there are 50 students, we'll assume 50 groups. Okay, now then we'll merge like maybe two students who are having most similar in height, who have similar height, and then we'll merge again the ones who have similar height like that, and we'll get like some 25 groups, 25 groups, and then again we'll group merge those 25 groups into something until we get like our desired groups. Okay, I think you understood what is this bottom up approach of hierarchical method. We'll take each student and we'll group them based on their characteristics, and then again those small groups again they will be merged until we get like some desired groups. And in divisive, we'll take whole class as one group. Okay, all the if there are 50 students, all the 50 students will be one group. Then we'll split them into smaller groups. Then we'll split again, we'll split again like that. We'll do till our desired groups. Okay, this is top down. Bottom up is like you're going from one group, one student, and you are going until you get some desired group. And top down is the reverse approach. You are considering all the students as a group, and then you're dividing them. Okay, so like that. Then okay, this tree whatever is formed is known as like it's known as dendrogram. Okay, that's what it produces, a dendrogram, which is the tree diagram. And from this diagram we can decide like at what point we will find the groups. Like see, in agglomerative it happens till it's bottom up, right? In agglomerative, till all the students form a group, we'll do till there, and based on the dendrogram we'll divide the tree. Okay, we'll not end up until desired groups. I mean, we'll in agglomerative we'll we'll merge the groups until we'll form a single group of all students, and a dendrogram will be formed. Based on the dendrogram, we'll see where should we stop. Okay, we'll see where should we stop, where did we get the desired groups. In same way for divisive also, since all students will be at the starting, all students will form a group at the start. It will divide and divide until they're like one groups, the tiny groups. And based on the dendrogram, we'll make sure where should we stop the clustering. Okay, like where should we cut the, the tree. So yeah, like this. Yeah, it can be, it will be like a family tree. How families keep on increasing, that's how it will be there. And then the next method we have is density based method. So okay, now in density based method, see, this is very different. Okay, this is very different. Instead of like forming a group, or like forcing each all students to form a group, or one student one group, here we'll based on dense regions. Okay, based on dense regions where it is where there are more data points, where there are more like where the area is very dense. Based on that, we'll form groups. For suppose a very good analogy I can give is, see, maybe you go to your canteen or a cafe or something, or somewhere, a food court. You can see, right, there will be maybe six people in one table. There will be four people in one table. See, from that, what can you analyze? Okay, these six people might be friends, yes or no? Like these six people are one group. These six people are a group. They are a group, they are friends. So you can analyze that, right? That's what is happens, like and for suppose you can consider them as groups. And for suppose somebody alone is sitting, we don't know what group they belong to, like what friends they have, we don't know, right? We don't have a group. But all these six people who are sitting with their friends, we can consider them as a group. We can consider, maybe if the three people are sitting, okay, sitting, we can consider, okay, these three people are a group. Okay, that's how it happens. Okay, that's a simple analogy I can give. So here also there is a popular algorithm called DB scan. Based on this, we can find like that. Like this DB scan will form a cluster. Like if it sees, okay, six students or they're sitting in closely together in one table, it will understand, okay, these are one group. So it will see the density. What is the density? More points. More points are there, then it will consider that as a one cluster. Okay, so this is also very useful. Okay, like I think one real life example is like in cyber security. When you are analyzing the network traffic, see, the clusters can represent like these patterns of activities. And and you can form clusters, like you can form clusters based on this patterns of activity. And like that. And if you see outliers, see, if you, the outlier here can be the lone, like the lone person. Lone people are like ignored, means for suppose there is a single person, that you will not group them, right? So in, if you see in cyber security, how is this useful is, all these clusters, they are like normal. Okay, based on the activities, they are considered as clusters and they're normal. But the outliers, maybe they're just like one person or two person in a particular area. Then you can understand, okay, this might be some suspicious activity, and they can use this. Okay, for when dealing, when you are when you are dealing with cyber security. Okay, and then one more we have, the last method is grid based methods. Okay, finally we have this grid based method. So here also, here the idea is like, we divide the space, we have the data which we have, into grids. For suppose you take some, see, if you take our India, like in India map, you how we are dividing into states, and then the states are like again divided into cities and all. See, like that. It's like you take, for suppose not like this. Wait, I'll say you one more thing. Um, like you take a city, for suppose take a city. how it is divided into like zones. Yes or no? Zones are there, right? Now, what can be useful is see in each zone, uh, they can measure like traffic density, how traffic is there, like about the traffic, and if on in particular grid where there is heavy traffic, like in particular zone, if there is heavy traffic, then we can understand, okay, here if there are more data points here, there is heavy traffic, and if it is light traffic, there will be less. So like, see, based on this, the authorities or somebody, they can identify like which zone is more more crowded, like which zone of particular city is more crowded. Yes or no? Based on the traffic, like if the traffic is heavy, maybe there that zone has more crowd. Yes or no? Like that we can do it. So grid based disk clustering can be useful when the data is like spatial or like geographical, because we are dividing them into groups, and it will be easy for for analysis visualizing the, okay, in visualization, the analysis is very easy. Okay, so this is based on a grid. This is about grid based method. Here also there is one popular algorithm. It is known as Sting. Okay, so these are the methods, like different methods for what clustering. See, partition is like you decide some you of beforehand only you decide how many groups you want, k groups. So you use methods like k means. Okay, and in hierarchical, what are we doing? We are building clusters like in a tree. You are building them like a step by step. You are building them step by step. Like you have two methods. What are those? Agglomerative and divisive. In agglomerative, you are building from bottom up. Okay, you're building from bottom up, and then divisive, you are building from top down. Okay, and in density based, you are forming clusters where the data is like where the data is very dense, and you will ignore the outliers. Outliers are like alone like thing. They are not dense at all. Maybe like 1 or 2 points. That's it. So for this, you are using DB scan. This is density based method, and then we have grid based method. In grid based method, what happens? We are dividing the space into grids, and we are forming clusters there, and we are checking based on that clusters. And here we have an algorithm called Sting. Okay, so this is about the types. Now, we know if our clustering model is good. How do we know? We use metrics, right? What we did for classification and what we did for regression, we used metrics. We used metrics like accuracy, precision, and all for classification, and we used MAE, MSE, all these things, right? What did we do there actually? We, based on the actual value and predicted value, you calculated error, or do you did things like that. What is the, and also what is the predicted category and what is the actual category, and you did some math there, and that's what is metrics. But now you might wonder, okay, like in classification and regression, the data is labeled, so we are calculating the metrics easily. Then how can we do for clustering? Yes. So see, it's basically, here the metrics are like how well how well the new point, or like the new point is fitting into the cluster. How well it is fitting compared to other clusters. Okay, how well each point fits into its assigned cluster compared to other clusters. Okay, so for this we have a metric called Silhouette score. See, it measures how similar a point is to its cluster versus other clusters. So this is the formula. Uh, See, here BI minus AI by max of AI comma BI. See, what is AI is, it calculates the average distance from point I to all other points in the same cluster. like it will calculate its point, its distance from this to the other cluster points. Okay, so it will tell them, it will simply this means what, how close I am to my own cluster people. Okay, how close I am to my own cluster people. AI is that average distance. Did you understand? Like, if there, suppose if there is this cluster and there are five people already, like five data points are already there in this cluster, and now the new point is put in this cluster. Okay, is put in this cluster, then this particular point will calculate distance for all the 5 points, for all the 5 points, and then it will take the average of that distance. Did you understand? This is AI. BI is uh, the distance from the point to its nearest cluster. Like, the cluster, it doesn't belong to the nearest cluster, it doesn't belong to. So it will check the distance between it itself with, I mean, the distance between itself with the other cluster. Okay, it will take that distance. See, if that distance is less and this distance is more, this here the average distance AI is more than BI, then obviously it doesn't belong in this group, right? So for that reason you will calculate this score. After calculating the score, you'll get see you'll get this SI, and SI value must be between minus, will be between -1 and 1. Okay, see now how this SI value will tell how our clustering whether our clustering is good or not. How this SI value will tell. See, if AI is much, like if AI is smaller than BI, much smaller than BI, so the point is close to its own cluster. Yes or no? It will be close to its own cluster. AI is closer to BI, and that means AI is smaller than BI. AI is smaller than BI. So, so then what will be the score? If AI is smaller than BI, the subtraction will give a positive integer only, right? The subtraction will give, the difference will give a positive integer only, positive value only. So you will get the answer, and you are dividing with by max, so the answer will obviously be between -1 and 1. So if the AI value is smaller than BI, then your SI value will be closer to 1, or like closer to +1. Okay, if AI and BI are like same, a little same, means the cluster is exactly somewhat in the middle of a new cluster and along with its clusters. So then then what happens? It will be like the AI and BI values will be little similar, and the answer will be like 0. Okay, the answer will be like 0. And if AI is larger than BI, obviously BI minus AI, right? So you will get a negative number. So you will get a negative number, and it means it will be nearer to -1. And what is the problem if AI is bigger than BI? If AI is bigger than BI, it means AI is what, the average distance between itself and its own clusters. So if it is big and if it is nearer to the other cluster, then that means this clustering did not happen properly. Yes or no? So your value will be nearer to -1. So it will not be good. So what we can conclude, if it is +1, the clustering is very good. The clustering is very good, and we did it properly. And it can, that point, that particular point can remain in that group. That I point can remain in that group. If it is 0, it's okay. The clustering is okay. It's fine. It can belong to both the clusters. We'll look into that later. Okay, that's not an issue if it is 0. But if it is -1 or like nearer to -1, then it is a big issue, because it is wrong clustering. Okay, the clustering is wrong. Like the point, basically the I which is belonging to a wrong cluster. Okay, it is belonging to wrong cluster. So that's why we use the similarity score to understand. Okay, it gives us like a numerical answer to judge the quality of our clustering. Okay, so do you guys have any doubts up till now? Okay, then maybe we'll discuss about k-means clustering. So, k-means clustering, as I said before, it is a partitioning method. Okay, it is a partitioning method, and we'll discuss about how k-means clustering can be done in a little detail. So we already had idea, right? So first, what do we need to do? We need to have some particular value for k. How many how many groups we want. So if you see here, there is a small diagram. There are some candies and there is a jar, right? So we want to divide our data into like k groups. So for suppose, let us suppose we want to divide this into two groups, so these candies. See, um, See, you have here mixed book. You have here mixed candies, right? Some candies are like red, some candies are like green, and some of them are yellow. So, like blue is also there. Now you have to divide this into k jars, and let us suppose we want two jars for two colors. So each jar should contain candies that are in like similar colors. Actually, here the four. Yeah, yeah, let's take four jars. Okay, then let's take four jars. So that means we want four categories. Okay, we want four categories. So what it will do, it, it will follow a step by step pattern. See, first we chose number of clusters, and then it will take some random place. It will take random centroids. So, like as I said, it is just a center. So at the beginning, like the algorithm randomly places k centroids, as I said, and see, it's like like you're putting some jars before, and you're just randomly putting some candy, four types of candy in there. Okay, like for suppose here there is, see, there's a small yellow one, there's a small green, pink and blue one. You can just put that randomly. Okay, maybe like that. And each data point will look around, will look like each candy will look and see uh, which centroid is like closest to me, like which candy is like closest to me. If you see the light pink, there is light pink candy and a dark pink candy, right? It might think, okay, I'm a little similar. The light pink candy might think, okay, I'm little similar to the dark pink one, so I'll be a cluster with it. Like I think I am. I think I will belong in that group. So that light pink candy will think like that. So then it will go into that particular jar. Like that, the candies can be divided. Okay, after like the candies are divided, the groups are assigned. Now the centroid is like, now they will calculate the average of that. Okay, they'll calculate average of that, and like see after all the candies are placed in the jar, see, we'll see what is the centroid, and we'll calculate like, okay, the light pink is there, the dark pink is there. For suppose maybe maybe red is also there in that. Red and pink, they might be a little similar. It might be a little similar. Maybe a peach color is there. If the characteristics are okay, maybe maybe they're like more dark pink candies rather than light pink. So the average will be like, okay, maybe it is like some dark pink. Okay, I mean, in this analogy, I'm saying like this. So like that, maybe like the centroids will change again and again until what particular groups are formed. Particular groups are formed. So we'll repeat this process. We will repeat the step three and four. What is the step three and four? Calculating the centroid again and again, like calculating the centroid, and then the each data going to its nearest centroid group. Okay, that's the process. Okay, so here you can see this is before k means all the like see, all of them are like in the same way, they're in same color. See, all these particular points they will calculate. Maybe you'll take the center values of you can see like there are three groups. Maybe they will take the center value, and Based on that center value, the groups will be formed. So this is after k means after we doing repeatedly. This is how perfectly the groups will be formed. So how do we know the right number of clusters? Like what is the right k value? We can use a method called elbow method. So in elbow method, what happens is we run k means with like different k values. We'll one will do the clustering for like for suppose k equal to 1 will do the clustering, k equal to 2 will do the clustering, k equal to 3 will do the clustering, k equal to 4, and so on. You will give each value, and for each k we'll calculate the similarity or like the error, something like that. And basically the error is like you might have doubt again, what is this error? We don't even have an actual value. It's like how far the points are from their centroids. Okay, that distance you will calculate, this kind of that distance, and then we'll plot a graph. So this graph will look like something here. It will look like this. So as k increases, you can see somewhere here like the error, I mean this kind of thing, this will drop here. Okay, so this means because more clusters, like the points are closer to the centroid, so this will be the ideal number of clusters. Okay, so this point, it looks like some elbow bent, like how our hand, we have elbow, right? How this elbow is bent, like this. The graph, like this point here, it looks like this. So that's why it is called an elbow method. So the elbow point is where the k value will be best. Okay, the k has the best value. So based on this elbow method, we can find the ideal k value. That means ideal number of groups. So like see, if you add more number of clusters, it will not affect that much, but there will be no improvement also. If you have more number of groups, it's waste, right? You have to have ideal number of groups. Okay, so that's how we can use this elbow method to find what is the ideal k value. Okay, and then we have strengths of what are the strengths, what are like the advantages maybe. See, it is simple and easy to understand, and it works like very fast, and it is very efficient on large data sets, and it works well, when clusters are like well separated. Okay, and like in spherical in shape, if you see in the graph, if they're like rounds, like perfect circles or spheres, it means the groups, they are like nice groups, they're like nice round groups. So like when you use for the C, if it is a circle, then centroid will be like the center of the circle, right? So it will be perfectly, all the distances will be quite similar. Okay, all the distances will be quite similar, and it works well. The k means, because we're calculating the average of this. So if the groups are like that, then this works pretty well with that. So nothing but if the data is good, and it's like the groups are very like different, like each group has some very different characteristics. I mean, if you take the small, medium, tall heights, obviously they're very distinct, right? The categories are very distinct. Okay, so unlike these candy ones or something, where maybe the sweet, like the sweet, or maybe the other things, there might be some like common characteristics where the groups cannot be that distinct, but here maybe the groups are very well distinct. So for these kind of things, k-means is very useful when the characteristics are very different, distinct for each group. Then then k-means works very well. Okay, so then we have some, but even though there are good characteristics, there are obviously limitations for this also. We need to know, like, we need to have some idea of how many clusters to make. So obviously, it you can use the elbow method, but it is not that great when you don't have any particular idea about the data and all. So you have to like tell the algorithm, right? Like you have to tell k means how many clusters to make. So which is not always, it is not possible. Okay, you can do sometimes, maybe you can use this elbow method and all, but it is difficult, and it is sensitive to like initial class centroids. See, if the starting centroids, we are initializing some centroids, right? 150 centimeters and 160, 180, something like that, we initialized, right? But what if I said 60 centimeters and 70 centimeters as initializing? Ideally, the students generally the heights are between 150 to 180 like this. But if I said 60 to 70 centimeters, that makes no sense at all. They're not like kids or toddlers or something. So the initial centroids also should make sense. They should also be like good values. If they are bad, see, if I said some 40 centimeters, 50 centimeters, and these people's heights are like 150, 160, then obviously it will all get messed up, and it will be very bad. And then we have and then struggles with clusters of different sizes or densities or like non-spherical shapes. See, as I said, I mean, if the density sometimes, see what happens. K means, it thinks, okay, all the clusters maybe have like different number of people or like different size. See, because it is calculating the average. I think you're understanding. If it is calculating the average, so it might think, okay, all of these clusters have similar size or like they're little same like that. So see, it is difficult. Like if you see here, see, you have here some shirts. Look, there are two yellow shirts and all, there are two pink shirts, and then there's blue. Yeah, this is when, you know there are like similar characteristics. A particular data point has similar characteristics to both, and it's not that, accurately we cannot put it into one group. See, this multicolored shirt, you can put that into yellow color shirts group, or you can put that in a pink color shirts group. We cannot say that, clearly it will belong to a particular pattern, sorry, particular group. So k-means can struggle when the data is like this. So that's why when the groups are very distant only, k-means can handle it very well. So that's how it works very well. That's how k-means work very well. So this is about the theory part for clustering for today. So like K means, what does it do? K means it will convert into K clusters using some centroids, and it will it will assign the points to its nearest centroids, and it will recalculate the centroids again and again until the groups doesn't change. So to find the right number of clusters, we can use elbow method. But sometimes, when the data is not that great and is distant, this method is not that possible. But still, if the data is good, if the data is like very distant and it's good, the groups are like good, then this can be useful. This method can be useful. It will be fast, and it is efficient, effective, efficient and all. So but if it is complex and all, the k means is a little difficult. Since for at a beginning stage, for beginners, this will be a good like introduction model for clustering. So I introduced this to guys. So now we'll deal with hands-on. We'll do a small model of clustering. So I want all of you guys to open like Google Colab. Yeah, before that, fill this attendance form. I want everyone to to fill the attendance form. Did you guys open Collab? Are you guys ready for hands-on? If so, put yes. Please fill the attendance form and get ready for hands-on. Okay, so let's start the hands-on, everyone. So, as I said yesterday, first, what do we need to do? We need to import the necessary libraries and all. So let us import the ones. And we have this module, right? Datasets module. It has all the datasets presently and present in it. So in day two, we learned about classification. In classification, we used this particular dataset called iris dataset, if you guys remember. So in iris dataset, there is this thing, like the the features are there, and then there are classes. We'll use that data set only, but we'll not use the target values. We'll just use the feature values and perform clustering. Okay, so for that, so let us start. We'll import our data set. I think my screen is okay, right? The text is okay, right? So from sklearn dot datasets, let us import load iris. I think you remember this statement. Okay, we did it on day two. After that, let us. I think you guys remember it. I don't need to show you guys how the data looks, right? I'll just show you how it looks so that we'll see what we are actually taking here. Pandas as PD. We are using this for a data frame so that we can see the our data set. And then df is equal to pd dot data frame just wait, I did not load. Okay, first we need to load. We need to load into Iris. We need to load our data. And after loading our data, now we are creating a data frame. Okay, we are just to know how the data is, how this data set is. Okay, so this is how we can create a data frame. Now let's, I think you guys remember about head, right? Head function. So we'll use that function to print the first five rows, first five rows. Okay, we, so these are the five rows. As you can see here, this is sepal length, this is sepal width, this is petal length, and this is petal width, which are the features of the data set we have. We are only using the features. Okay, we are only using the features. Okay. Um, so we are not using the target values here because for clustering, we are we don't need the target values, right? We are just clustering based on the features. Like we are clustering based on the input features. So the patterns, we are just identifying the patterns and we are doing the clustering based on that. So we are not using target values here. So we'll just use these features and cluster. Okay, and then next we have now we'll do the clustering. So we don't need to even have the test and training data, like the data part, because like there are no labels and all, right? So we'll build the model directly. So from sklearn dot, so for here you will use cluster to import the model. You will use this module named as cluster. So in that you will import k-means. Okay, k-means. From sklearn dot cluster you will import k-means. And now we'll load our model into this. K-means equals to k-means of n underscore clusters equal to, let us put the number of clusters as 3. So we'll put it as 3. K underscore clusters equals to 3. And let's put the random state equals to 42. I think you guys remember about the random state part. Now we'll okay, we'll run this. Yeah. Now what we are going to do is we'll put a we'll put a data set here. Okay, we'll put, like, sorry, not, we'll put a column here where it stores um, like it stores the clusters names. Like as I said, there are no labels, but we should categorize it into something, right? We should categorize into maybe like it's cluster 1 or cluster 2, something like that. So we can put cluster here equals to k-means dot fit underscore predict. Okay, fit underscore predict. And we'll just put iris dot data. Okay, we'll put iris dot data. So Here the predicted clusters will be in this column, will be in this cluster column of our data frame. So yeah, I'll print. Now if you print df dot head, see, I think you can see here, right? The cluster, how the cluster is formed. This is cluster 1. Based on the characteristics, a cluster 1 is formed. Okay, so there is no name for it. If you remember on the classification day, if you remember there, we classified into classes, right? Class 0, class 1, class 2. They're already labeled data, they're already having classes. So the new parts, the new ones, they can be divided. See, they can be divided based on the classes. Now here we are just dividing the entire data into clusters. So that's why there is no need to give training and testing, because training means that it's already sorted and all. But in the clustering part, the data is not at all sorted, right? I mean, the data is not at all classified or categorized. So we need to perform for the entire data. That's why there is no test data or train data, or there are no x test x train or y test y train. There are nothing of these, because we are dividing the entire data set into clusters. So for that reason, we are doing this. The next, see, this is how the clusters are formed. Okay. Now, we since we know that, like, see in iris dataset, it generally has three categories, so that's why we can assume that the k value is like 3. Okay, so that's why we did here, and we did the clustering part. So now there will be like three clusters: cluster 1, cluster 2, and cluster 3. Now what we are going to do is, let's plot this cluster, so that I think you guys can understand it easily. So obviously, I think I said about plotting yesterday. We'll use this library called matplotlib. It has a module like pyplot, which has so many functions like plot, scatter. If you remember scatter is about the points. And then if I said, if it is plot, it is like you're plotting the relationship. In linear regression yesterday, we did that. So we can use that one. So for that, we'll use plotting. We'll use this matplotlib library. So let's import that. Import matplotlib. So import mat matplotlib dot pyplot as plt. Okay, this is pyplot. We're importing this. Okay, import matplotlib.pyplot as plt. Now let us plot the this graph such that we can understand it. So what do we need to plot here? Scatter or plot? We need to use scatter, right? Because we are taking each individual point. So for scatter, we will get that. So we have to use this thing called scatter. Okay, let's have that function. Let's use that function plt dot scatter. Okay, then now we have to give iris underscore, sorry, we just named it as df, right? Df, and you can give the column name. I think you can see here petal length centimeters. We'll give this column name here. Okay, and then we can give another column also. This time we'll give this column petal width. Okay, we'll give petal width, and I think we'll plot based on these characteristics. C equals to df dot. What is this part? What is the clusters one? We named it as cluster, right? We named it as cluster. We are using this column. Okay, we are using this column for this here. Okay. Now we'll use this called CMap. Okay. And then we'll put s equal to 50. So you can see the clusters here, right? Okay, these are the clusters. You can see here. 1 minute. Okay, you can see the clusters here, right? The yellow part, the violet part, all of those. So let us, as I said yesterday, we can use something like X label and Y label also. We'll use them also here. Okay, so actually, if you see properly, I think I didn't say about this, right? The C map means it will just give like color map. Okay, these are just the color codes. You will get some color. That's it. Okay, there is nothing like technical term for this. So yeah, we'll now plot about the. We have some other function also like k, x label, and y label. We'll use this such that our graph can be easily understandable. So what did we use for x? If you see here, we used this particular thing, right? This particular column for x. Sorry, yeah, this particular column for x-axis. We are plotting the graph for petal length versus sorry petal length versus petal width. So the x label will be petal length. Okay, the x label will be petal length. And what will be the y label? Y label will be petal width. Obviously, we are plotting for that, right? We're plotting for petal length and petal width. Plotting for petal length and petal width. And also we can use something called another function plot title. I will just put here k means clustering. Okay, and then I can just put here, yeah, that's it. Okay, wait, um just here. Okay, I think now you can understand this graph in easily, right? If you use this thing, um, here you can understand we can use these kind of functions to make sure the user can understand it easily. Here we have the title k means clustering, and we can name the x-axis and y-axis also. So in this way, we can plot the graph or whatever. You can see here this green part is like one cluster, this yellow part is one cluster, and this violet part is one cluster. So our data got divided into three clusters. Okay, our data got divided into three clusters, and we can easily see these clusters. Okay, based on the characteristics and all, we can see here we used only petal length and petal width. You can change the columns also. Like for suppose I'll just change it into sepal length and sepal width. So now if I run again, see, now it is very different from the previous one, right? It is very different because for this type of characteristics, the clusters are like this. So this is one cluster, this is one cluster, and this is one cluster. The before features what we used petal length and petal width, it was different, and for sepal length and sepal width, it is different. Okay, so this is how you can perform clustering. So I think you guys understood what is all this, what is clustering and all. In classification and regression, there are type of supervised learning problems. Okay, they are supervised learning problems, and they have labeled data. And in unsupervised learning, we have unlabeled data. So here you are using clustering. Okay, here you are using clustering. So that's what is about unsupervised learning. If you guys have any doubts, you can ask me. If you don't have any doubts, let's end the session. Okay. So that's it about clustering, guys. Tomorrow we'll discuss about reinforcement learning. Tomorrow is the last day, and we'll discuss about reinforcement learning. And I'll also tell you about the roadmap, how you can learn further ML, what steps you can follow. So I'll tell about that, and tomorrow, don't miss tomorrow's session. We'll discuss about reinforcement learning, and we'll discuss about like what further. Uh, I'll just give you a small roadmap. What further things you can learn about ML, like some resources also. I'll give you those resources. So that's it for today's session, guys. That's it for day 4. Thank you for joining for today's session.